Exponents are basically, it's just another word for powers, but there are 5 main topics that we have to deal with when we're talking about exponents, or 5 main operations. So first we have the situation where you are multiplying 2 similar bases. For example, x and an x, or y and a y, or 5 and a 5. And if either of them have an exponent or power, what we're going to do is, and I don't know how well you can see this, but it says add the powers. So here's an example. I have a 2x to the 5th times a 7x to the 4th. The 2 and the 7 still get multiplied. That's just multiplication. But now I have 2 bases that have exponents, and the question is, what do I do with the powers? Well, since I'm multiplying, I add the powers. So 5 plus 4 is 9. So I get 14x to the 9. Let's try another one. Doesn't matter if it's a variable or a number. When I multiply, I rewrite the base. Remember, the base is the main variable or number or value, and the power is your exponent. 3 to the 2nd times a 3 to the 4th. We just rewrite it, and we get a 3 to the 6th power. So we add them together and get 6. But you should never, ever, ever leave 3 to the 6th power. You can figure that out. If you can't do it in your head, then use a calculator, but the final answer is equivalent to 729. A variable you can leave to a power, but a number, All right, when dividing. So first we had multiplying. Now what we're going to do is take those same bases and divide them. What happens? Well, we subtract the powers. So here's an example. I'm going to divide 6x to the 8th by 3x to the 4th. Now, 6 and 3, they're not powers or anything, they're just numbers. So you're still dividing them. 6 divided by 3 is 2. X to the 8th, divide by an x to the 2nd. Now I'm going to subtract the powers and get an x to the 6th. In this example, what I wanted to do is stress that concept of the similar bases. You can only be applying these rules when you're talking about an x and an x, or a y and a y, or a 3 and a 3. I could not compare an x and a y and add them together and get a 14, because they're not the same base. But this x to the 5th is the same base as this x down here. So I can simplify those. And I'm subtracting, I'm dividing, which means I'm going to subtract the powers. This one doesn't have a power or an exponent. It does, but I don't see one. It's an understood 1. So if you want to add a 1, if that helps you, that's perfectly fine. And so now when I subtract the powers, 5 minus 1 is 4. And then with the y's, I write the base and subtract the powers. 9 minus 2 is 7. Okay? So we have multiplying similar bases, add the powers, divide similar bases, subtract the powers. And by the way, if you look under assignments, some notes on this, on just a single piece of paper, they are there. I believe it says Guide to Exponents. So if you look under assignments, you can get this in writing also with some additional examples. Number 3, when raising an exponent to a power. Okay? For example, like this. All right, what am I going to do? I'm going to multiply the powers. So x to the 5th to the 4th power gives me an x to the 20th, because 5 times 4 is 20. Be careful, because 3x to the 5th to the 2nd power, many people will get the x to the 10th part right and totally forget that you are still supposed to raise the 3 to the 2nd power. 3 squared is 9. X to the 5th to the 2nd power means multiply them and get x to the 10th. So be careful about that. What happens when you have a negative power? A negative power, what it does is it makes it into a fraction. So any value that you have that is negative, we first want to go ahead and just make it positive by moving it to the bottom of the fraction. So an x to the negative 3 would be the same thing as 1 over x to the positive 3. Be very careful though. The only thing being raised to the negative 5 power is the x, not the 4. So the 4 does not get moved to the bottom of a fraction. So what I'm going to do is I'm just going to leave my 4 where it is and move the x to the bottom of the fraction. And once you move it, you can change it to a positive. You must change it to a positive. And then I have my answer. This one's tricky because if I move my value, this whole fraction, x over y squared, is raised to the negative 4 power. If I move all of that to the bottom of a fraction, I have a fraction with a fraction in it, it gets messy. So, it's kind of what you would assume. If I have to move something to the negative power to the bottom of the fraction, what if it has a negative power in the bottom of the fraction? Where would I move it? Back to the top. So my x is going to get moved to the bottom because that's a negative power, but my y is going to have to get moved to the top. One way you could look at this is you could distribute and get an x to the negative 4 over y to the negative 8, because remember, when you raise a power to a power, you multiply. So this power is a 1. 1 times negative 4 is negative 4. 2 times negative 4 is negative 8. So you could do this step first, raise them to that power, and then take advantage of the fact that you're not allowed to have a negative in your answer. So the x would get moved to the bottom, and the y would get moved to the top. Another way you could look at this is dealing with the negative first. I could just deal with the negative, and remember, when you switch, that's when you make it positive. So if I deal with the negative and move the x to the bottom and the y to the top, that works also. And then when you raise it to the 4th power, you get y to the 8th over x to the 4th. Both ways should give you the exact same answer. And then finally, number 5, last operation, is when you have a fraction as your power. When your power or exponent is a fraction, you need to change it into radical form. What do I mean by that? Well, y to the 1/3. The 1 doesn't make this a fraction. The 3 does, because I have a denominator. That is the value that goes in your radical. So if this is the 1/3 power, then I'm going to take the 3rd root. That's that number at the bottom, the denominator, is what will go in that little nook of the radical sign. So I have the 3rd root of y to the 1. So, same thing. This is a 4 over 5 power. So, what goes in the little nook? The 5. And then I still just have an x raised to the 4th power. This is a slightly different situation because both the 2 and the y are being raised to the 1/2 power. Now, let me get my radical ready. The 2 at the bottom of this fraction, I should probably change this. I don't want to have 2 2's and have you not be sure which one I'm talking about, so I'll make it a 4. Okay, 4y to the 1/4. This 2 is the number in the denominator, so that's what goes in the radical. But you know what? We don't have to really write that. That's a square root. A 3rd root, a 5th root, that's a square root. And a square root is the same thing with or without the 2, because there's an understood 2 here already. So either way, if you want the 2 or don't want the 2, it's okay. And all of the 4 and the y go inside the radical. All right? Okay, so all the assignments are posted under Assignments 2 for 2nd semester. And the note sheet that also has some additional problems and examples is also posted under Assignments 2. So that's the guide to exponents. Good luck. All right, bye.